Transformations. What transformations are shifting, reflecting, and stretching graphs. What I'm going to do is just briefly go over what this may look like and then give you some examples to better explain it. So what we want to do first is look at some notation that you're probably not going to like too much. So first thing you notice, I have y equals f of x. F of x is nothing but a fancy way of saying y. So let's pretend that where you see all these f of x's, that they're actually y values. So like for example, this f of x plus c, that's the same as a y plus c. So if you think about it, if you take a bunch of y values and add c to them, it's actually going to cause them to move up c. And if you subtract c, that means they're going to go down c. C is just any number. Let's say any whole number. Now when we come to f of x plus c, notice that this c is inside the parentheses with the x, and so is this one. So anytime it's like that, we're going to move left and right, because since it's with the x, it's moving horizontally. Now what you have to watch out for is if it's a plus c, it's going to move left, opposite of what you might think. And if it's a negative c, then it's going to move right, which is opposite of what you might think. And then we have a couple more that involves flipping. I call it flipping over the x-axis or over the y-axis. Now you notice we have f of negative x and negative f of x. Now this f of x, negative f of x, is the same as negative y. So keep that in mind. So what I'm going to do is I'm going to draw a little xy plane. First off, let's look at where we have negative x. So over here on this side we have positive x's. Then over on these two quadrants we have negative x's. So if you were to take this right side, go from the positive x to the negative x's, it's over which axis? And as you can tell, it's over the y-axis. Now let's look at what happens when we go from a positive y to a negative y. Notice this negative in front of f of x or negative y. Up here they're all positive, and down here the y's are all negative. So if you go from a positive to a negative y, that's over the x-axis. That's the reason for the x-axis. We'll show you some other ways to look at it, but that's what's going on. Now on these, once again, anytime you see f of x, think of it as a y. So this c has been multiplied by the f of x. Once again, we're going to think of c as being a whole number, but for this case, c is going to be greater than 1. It could actually be any real number greater than 1. And the same thing is true up here. We could have decimals for our c, but for the most part, they'll be whole numbers. But you may see decimals, so be aware. So if you're taking a c greater than 1, some number greater than 1, and you multiply it by y, it's going to make those y's become, or the graph become, a whole lot sharper, or more vertically. Or in other words, it's going to stretch it vertically. It's going to make it vertical more quickly. Now if you take a decimal or fraction less than 1 but bigger than 0, like a 1/2 for example, it's going to take the f of x, if it's a 1/2, it's going to cut those y's in half, which is going to shrink it vertically. Now these other two you have to watch out for, kind of like with the signs up here. If the c or the number has been multiplied on the inside of the x, and the c is greater than 1, you would think that's going to make the graph bigger, which it will vertically, but it's actually going to shrink it horizontally. It's a horizontal shrink because of where the number is. It's inside the function being multiplied by the x. And the same thing down here. If it happens to be a fraction, it's going to take all those x's and it's going to shrink them, or stretch them out, horizontally. So watch out for the horizontal and the right and left stuff. It's the opposite of what you might think. So what I'm going to do, I'm just going to look at f of x equals the square root of x. And so what we have, first off, the graph looks something like that. And to show you how this up C and down C works, let's just take any number we want, and we're going to add, let's say we use 2, so we're going to add 2 to the function. Notice the original one is still at 0, 0 as far as where it starts, but when we add 2 to it, it moves it up 2. Now notice this one, when we subtract 2, it's going to move it down 2. Did you notice that? Down 2. Now let's see what happens when we actually take the function and we move it, or the number, and we move it inside the function. Like in this case, the minus 2 is inside the x. We're taking the square root of x minus 2. And if you need to see what I'm saying, the first one I did was the square root of x, and then plus 2, and then the square root of x minus 2. The one I'm currently looking at looks like this. Notice the difference. The minus 2 is inside the function with the x, so it's attached to the x. So it's going to go left to right, but that sign's going to tell you that it's going to go right to. It's the opposite. See it? Now here's an explanation that you won't see in a textbook, so I'm going to tell you now. Notice that we have the function at 0, 0. And since it's the number's attached to the x, it's going to stay on the x-axis, which means the y value is going to stay at 0. So we're thinking, what is the x value that's going to cause the whole function to stay at 0? Well, what kind of 2 do we need to substitute in there to get a 0 for the answer? Well, if you think about it, we need a positive 2, because 2 minus 2 is 0. So we would expect to have the point 2, 0. Hence the reason for the opposite. That's what's going on. Now, just so you know what's going on, furthermore, let's do plus 2. So, if you think about it, this is going to stay at the y value of 0, which means we need a x value of negative 2, which in other words, if you have a plus 2, instead of using 2 to the right, you're just going to go 2 to the left. That's what's going on. And now, let's clear this out. This time we're going to do a couple signs. First time we're going to use is the one on the outside. So it's like taking the whole function and making it negative because it's on the outside. So it's on the y's, all the y's. So it should turn it upside down. Goes from positive to a negative. Now let's move the minus sign on the inside. And you may be thinking, I can't take the square root of a negative number. That is true on the real number system, which we're working on. But that must mean, though, that these x's will all have to be negatives. So in other words, it's going to take it, make the x's go from a positive to a negative. Remember, positive to a negative. So when we graph it, it's going to flip it over the y-axis. See it? Positive to negative. Now, the next couple examples you're not going to like because the calculator really isn't going to help you, but I'm going to show you anyway. It's with stretching, shrinking. So we're going to do the vertical. So we take 2 square root of x. It makes it more vertical quickly. Makes it vertical more quickly. And I could use 1/2. Well, we can go ahead and use 1/2. And what it's going to do is, see that? It's not as vertical anymore. Not as vertical. The first one that pops up is always the original graph. So you can actually see the vertical, but you're not going to like it for this reason, because it's going to look a whole lot similarly when you throw the numbers inside, like a 2x, square root of 2x. You got to think horizontally and vertically, or not vertically, but horizontally. Remember, since the 2's with the x, we're thinking horizontally. It's not as horizontal as it used to be. It shrunk it horizontally, made it more vertical, which means it shrunk it horizontally. So what we're going to say then is, since the 2's with the x inside the square root, it's a shrink, a horizontal shrink. Yeah, it's kind of confusing, I know. But that's just the way it is. It's all about placement of the number. In this case, the number's inside the x, being multiplied. Once again, the stretch and shrinking, or some books call it compress. If you see shrink, it's also compress. So just be aware. In this case, it's going to make it more or stretch it out horizontally, because it's with the x, we're thinking horizontally. See that? Stretch it out horizontally. So if you're given a graph, it's kind of, and you ask to determine if it's horizontally or if it stretches or shrinks horizontal, vertical, you really can't tell for the most part. So just be aware of those. So more times than not, you'll actually be given the function. Once again, shrink is the same as compress. So let's do some examples of types of problems you might see. It says write an algebraic expression that transforms the graph of y equals x cubed by shifting it 4 units to the right and down 3. I'm putting function notation. So I have shifting left and right and up and down. So what that means is I'm going to need my basic function, which is x cubed, and I got numbers on the inside and on the outside. So 4 units to the right. It sounds, and that's going to be on the x because x is going left and right. So now I'm going to have the 4 with the x being added or subtracted. But since it's to the right, I'm thinking opposites with the x's. So that's why it's a minus sign. But then down 3, the y's go up and down. And I always use a sign that I think it should be in this case. So down is minus 3. The one you have to watch out for is inside the x, inside the parentheses with the x. Here's another one. We're going to take the absolute value of x, so we're going to stretch the graph vertically by 3 and across the x-axis. So we're going to stretch it vertically, which means we're going to, that's the same as y's, up and down. With the y's, it's pretty much what you think it's going to do. It's going to take this absolute value of x, and we're going to stretch it vertically by multiplying all of these y values found from the absolute value of x. I may have said square root, but the absolute value of x. It's going to stretch them all vertically by 3. So that's, since it's a y, it's on the outside as you think it is. Now if it were horizontally, I'd have the 3 on the inside. And actually it'd be a little different also. It would have the different word there. Now across the x-axis, once again, let's just draw an x-axis. You want to? Here's the x-axis. Well, up here we have positive y's, and down here we have negative y's. So since it's going across the x-axis or over the x-axis, we're changing our y's from a positive to a negative. Once again, all information about the y's goes on the outside, so we're going to change the sign from a positive to a negative. So we're going to put the negative right on that 3. So the 3 involves the stretching vertically, and the negative involves which axis it's flipped over. Understand that? It always pays to draw graphs whenever in doubt. Now let's consider this function. But before I answer all these questions, I need to rewrite it to where it makes a little bit more sense in order to answer these questions. So the first thing I want to do is take that 4 that's being multiplied, because it is on top, it actually is being multiplied by 1, and I'm going to bring it out in front. Instead of the 1 on top, or the 4 on top, I now have the 1. Then 2 minus x squared plus 3. I'm just using brackets so you can see that I just took the minus, or the 4 out. And if you want to check, if you multiply it out, negative 4 times 1, or 4 times 1 is 4, because you multiply numerators. So I want to bring the 4 out. The next thing I want to do is worry about this 2 minus x. First thing I want to do when I look at it is rearrange it to negative x plus 2, because the minus sign is on the x and 2 is a positive. Then I'm going to factor out a negative 1 or just a minus sign. So when I factor out a negative, it's going to change the sign of each of these. So that's how I want to look at the 2 minus x. It's negative parentheses x minus 2. So my function is now going to look this way. It's the same function. I've just rewritten it to where I can answer these questions a lot easier. So I need to put that negative parentheses x minus 2, and I need to put that in another parentheses with that square, and then plus 3. So the main thing is this 2 minus x needs to be written as negative parentheses x minus 2. So now we can answer these questions. For the first one, identify the more basic functions been shifted, reflected, stretched, or compressed. Compressed also means shrink. I'm going to use y equals. If I take out all the minus signs and all the non-1 numbers like the 4s, 2s, and 3s, what's left is the 1 over x squared. That's the most basic function. Remember, I'm just taking out all the 4s and the 2s and minus signs. I'm keeping the exponent, keeping the x, and keeping the 1s. That's what's left over. Now let's see what happens. Let's see what all these do to 1 over x squared. Let's just start go left to right. That minus sign, that minus is on the whole function. And the whole function is a y. So what it's doing is it's taking the y's from a positive and now making them negative, which means it's reflecting it over the x-axis. I'm going to do some abbreviation here. Now this 4 is taking all these y's and it's multiplying by 4, which means it's making them bigger quicker. So what that is, it's going to stretch it vertically. The y's go up and down, which means they go vertically. The 4 makes them bigger, so it stretches them vertically. Now this minus sign is on the x. So it's going to take the x's from a positive to a negative, which means it's over the y-axis. Now this minus 2 is where we have some differences depending on which book you use. The book that we're using for this video means that I had to rewrite it like this, so we know that since the x is on the 2 and x's go left and right, and we do the opposite sign or opposite way, it's going to go right 2. So that's the reason why I had to write it like this. If you see another one of my videos, you may see me doing it a different way. Well, that's from a different book, so just be aware. And then this plus 3 is on the whole function, which means it's on the y, which means it's going to add 3 to all the y's, which means the y's go up or down. Since it's a positive, we're going to go up 3. And that's it. Just be careful with which book you're using. This one, well, let me try to clean this up first. Some of these things are in my way and they don't need to be there. Just a little cleanup. You can fast forward through this if you want to. Okay. We're going to take this graph and we're going to draw two graphs. The first one is we're going to draw f of x plus 2. All you're given is the actual function, or the f of x, the graph of the function. And then we're going to take that function, we're going to, what this plus 2 means is move it up 2. And as f of x is the same as y, so it's like taking all the y values, I'm going to add 2 to them. So here's what I would do. See this point over here? This is a negative 4, comma 0. See this point is 1, comma 5, and this point is 6, comma 0. So all I'm going to do is take all these 3 points, because these are just like basic points to look at, and I'm going to take the y values and add 2 to them. Well, if I could draw a straight edge a little bit better. Yeah, you get the idea. So if I take the negative 4, comma 0, if I add 2 to the y value, I get negative 4, comma 2. So let's plot that point. I'm going to use right here 1, 2, 3, 4, and then up 2. Now 1, comma 5, when I add 2 to the y value, becomes 1, comma 7. So let's go right 1, up 7. 1, 2, 3, 4, 5, 6, 7. I think that's 7. 1, 2, 3, 4, 5, 6, 7. And then 6, comma 0, when I add 2, becomes 6, comma 2. Looks like a B. 1, 2, 3, 4, 5, 6, 1, 2. And I'm going to freehand connect them. Now you get the idea. So all this has been moved up too. Now let's do f of negative x. Now what this is, we're going to do pretty much the same thing. Ooh, that one's a little bit better. Look at that. Sometimes I amaze myself. So this f of negative x, all that means is I'm going to take these x values, negative 4 is 0, and that's going to be, and I'm going to change the sign on the x value. It becomes a 4, 0. 1, 5 becomes negative 1, 5, and 6, 0 becomes a negative 6, 0. So let's plot those. 4, 0, 1, 2, 3, 4. Negative 1, 5. Negative 1, and then up 5. And then negative 6, 0. So what happened is, we took the x values and went from a positive to a negative. So we like took this whole graph and we flipped it over. This part went over here and this part went over here. So we expect this right side to be longer on the left side now, and the shorter side on the left will now be on the right, which it looks like that. Trust me, it does. And that's it for this video.